In this video lesson, we will learn about transversals. So first of all, transversal is kind of a weird word. What we're really talking about are parallel lines. And a transversal is actually just a set of parallel lines with another line intersecting them. So this is an example of a transversal. And there are a few important properties of transversals, all of them relating to angles. So let me label this properly. We have line 1, line 2, and line 3. And the properties go as follows: that these two angles are equal, and then these other two angles are equal to them because they're opposite angles. And then there's an entirely different set of angles. This was 4 angles so far. And this other set of 4 angles are also all equal to each other. So this is the main property of a transversal. Half the angles are all equal to one value, and the other half are all equal to another value. So let's do some sample problems and calculate some angles. So we're given this 127 degrees, and we're asked to find the measures of all the other angles. And of course, it's assumed that the two lines that are parallel to each other. So first, angles 2, 4, 7, and the given are all equal because of the properties of transversals. So I'm going to label here 1, 2, 3, 4, 5, 6, 7. And we know that 2, 4, 7, and the given angle are all the same. So they all have to be 127 degrees. Now we have to find the remaining 4 angles. The angles 1, 3, 5, 6. So let's say angle 5 is equal to x. Then x plus 127 degrees has to be 180 degrees because they make up one line. And we can just solve this for x by subtracting 127 on both sides, and we get 53 degrees. So x is 53 degrees, and that's angle 5. But angle 5 is the same as angle 6, angle 5 is the same as angle 3, angle 5 is the same as angle 1. So all these angles are equal. So calculating 53 actually told us the remaining answers. Just write it down: 53 degrees, 53 degrees, and 53 degrees for numbers 1, 3, and 6. And of course 5. And that concludes this problem. So as you can see, the properties of transversals make it really easy to calculate all of these angles, just knowing one of them. Alright, let's do another problem. Here we have to find x. So first of all, this angle is the same as these 3 other angles. And in particular, we can write it down here, and we see that here it combines with the other angle to make a straight line, so 180 degrees. So in other words, the two given angles, when added up, have to equal to 180 degrees. Well, that gives us an equation to work with, so now we can try to solve for something. We just add them up. 3x plus 6 plus 6x plus 12 is 180, all of this in degrees. And we add this and we get 3x plus 6x is 9x, 6 plus 12 is 18. I'll fix that in just a second. And this equals to 180 degrees. 9x plus 18 there we go. So 6 degrees plus 12 degrees is 18 degrees. And then we subtract 18 degrees on both sides, and we get 180 minus 18 is 162. And then we divided by 9 on both sides, and 162 divided by 9, whether you work it out by hand or use a calculator, you will get 162 over 9 is equal to 18. So x is 18 degrees. X equals 18 degrees. And that concludes this problem. All right, now one last problem. This problem will be an application of this knowledge to parallelograms. So we have parallelogram ABCD has angle A equal to 37 degrees. Find the rest of the angles. So first of all, a parallelogram is just two opposite pairs of parallel sides. And I'm just going to redraw this to make it closer to 37 degrees, but that's totally optional. So here it is. So each pair of opposite sides is parallel. And I'm going to label this A, B, C, D. So I want to find the rest of the angles. So how do we do that? Well, remember transversals are all about sets of 3 lines, 2 of which are parallel. So what we're really going to do is we're going to ignore one side and work with the other 3. So this is what we look like when we remove CD and we sort of extend the lines. And this is exactly a transversal. And we know that angle A is equal to 37 degrees. So there I label 37 degrees. And then let's say B is going to be X. Well, X plus 37 degrees has to equal to 180 degrees. The reason for that is, for example, X is equal to that labeled angle, and together with the 37 degrees, they make 180 degrees. And now we can just solve for X, and we get X equals to 143 degrees. So we solved for X, all right, or solving for X gave us angle B, but we still have 2 angles left. What do we do for that? Well, the same thing as before, but this time we're going to ignore a different side and include another one. I'll show you what I mean. So here I've included another side, and that gives us the points C and D. But now we don't care about the side AC. We're just going to erase it for now. Erasing it's optional, but it'll help clarify what we're doing. And we know that angle B is 143 degrees, and now we're trying to find Y, which I labeled angle D with. But for the same reasons as before, Y plus 143 degrees equals 180 degrees. And that just gives us Y equals 37 degrees. So angle C is 37 degrees. And of course, finding angle D should be easy from here. In fact, you might already guess what it is, but we'll do the full work anyway. So now we're looking at the transversal of the 2 parallel sides intersecting side CD. We have 37 degrees for C and an unknown for D. And we'll label D with Z. And Z plus 37 degrees, as before, equals 180 degrees. So Z equals 143 degrees. And there we go. We found all of the 3 other angles. And notice that the opposite angles of a parallelogram are equal. This is actually always true about every parallelogram. And of course, the main fact that we used was that the adjacent angles, the 2 angles that are next to each other, add up to 180. So this concludes this video lesson, and thank you for watching.